Don't forget to subscribe and ring that bell.
Hey, welcome there. Visca the teacher here, and with the Algebra 2 Regents exam for 2024 for June, about a week away, I decided to do the January 2024 Algebra 2 Regents examination. So, this is the first video. We're going to do problems 1 through 8, and as usual, we always get a calculator. Just a quick note, there are 24 multiple choice questions here, and each one 2 credits each. We don't get any partial credit. You either get it right and you get 2 points, or you get it wrong and you get no points. Let's go. Number 1 reads, a cafeteria food manager studied the lunchtime eating habits of a group of employees in their office building. The purpose of the study was to determine the proportion of employees who purchased lunch in the cafeteria, brought their lunch from home, or purchased lunch from an outside vendor. This collection of data would be best classified as. All right, it's not a census. Um, that's when you send paperwork out and have people, fill it out for you and return it. It's not an experiment. He's not experimenting on people whatsoever. Um, it's not a simulation. We're not going to have a computer simulate it. He's going to just observe people, or they are going to observe people. How terrible of me to assume that it's a man doing this study. But whoever's doing the study, they're going to observe the people. Okay, the eating habits. You're going to see who's bringing in what and from where. That's really it. Problem 1 is done. Problem 2, which graph has imaginary roots? All right, if you didn't know this, roots are the same thing as zeros, solutions, okay, and x-intercepts. This is the big one when we have graphs, okay? So I'm going to look here, and if it's imaginary, that means there's nothing real, which means it doesn't really touch the x-intercept, okay, or excuse me, the x-axis, okay? This one touches it at 1 point, so it's not this. Choice 1 touches it at 2 points, not this one. 4 also touches it at 2 points. No, 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 no. Choice 2 is the only one where it does not touch the x-axis at all. There are no real solutions because it doesn't really touch the x-axis. You're welcome. Right, number 3, let's actually start to use the calculator. Right, given 3 is a root of f of x, which is x to the fourth minus x cubed minus 20x squared plus 45x. What are the other unique roots of f of x? Again, in problem 2, we said roots are the same things as x-intercepts. So I'm just going to graph this right here and see where it touches the x-axis. Can I do that for somebody, please? All right, well, spinning circle of death here. There we go. There it is. Oh, there's a calculator, and let's move this. We'll move this down so we can see the equation we're graphing. So I'm going to turn this bad boy on. I'm going to go to y equals, and I'm going to put in there x to the fourth, pop off that exponent, minus x cubed, pop off that exponent, minus 21x squared plus 45x. Now I'm going to start graphing this on my simple 10 by 10 window. And let's see what we get here. Up, but goes down, up. Oh, it looks like it touches to me right here, and right here. Okay, oh, I like that little circle thing. That's cool. So let's bring this out. Oh, you. Oh, you. 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 What do I gotta use my finger? No, you know what? Kids, Mr. Visco will be okay. Let me get the arrow. All right, now we're back. It touches here, which is -5. It touches here, which is 0. And it touches here, which is 3. All right, so we have -5 0, and 3. But it tells me 3 is already given. It wants to know what the other unique roots are. -5 and 0. And that, my friends, is choice 2. Wow, a little bit of a technical difficulty there, but we're cruising. Guys. Guys. All right, given that P does not equal Q. Okay, thanks for that. They give us this expression. P equals 1/2 Q raised to the Q. Expressed in logarithmic form, which one of these is equal? So if P equals 1/2 Q, all right? When I put something in log form, okay? When I put something in log form, I really flip, okay, the exponents and what it's equal to. For example, if I have log, okay, base, I don't know, 5 of 25, it's really asking me what exponent of 5 is 25. Well, it's 5 squared. How do I know that? Because if I drop this log, I literally switch the exponent and what it's equal to. All right? Except we're not starting with a log and getting rid of it. No, 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 my friends. What we're doing is we're starting without the log and adding it back in. So I've really just got to switch my exponent what I'm equal to. Right. 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 So let's switch these two and bring the log back in. So I've got log, the 1/2 is my base of P equals Q. And there you go. And that's what I'm looking for. And that, my friends, is choice 3. All right, number 5. We're doing good. 7 minutes in. Which graph best represents the graph of f of x equals x plus a squared times x minus b? Now, we need to be careful with this because it tells us that a and b are positive real numbers. So the first thing I do is I know a and b are positive. And they're saying which one of these graphs could represent this function. Well, I feel like this is a common theme, right? If I go back here to 3 and 2, root is the same thing as my x-intercepts, right? Okay, there we go. There we go. And then we go back here, roots, x-intercepts. So this is kind of a big theme for at least this specific test. So if I were to solve this, and I say x equals, I guess I'll start with minus b. I like to go right to solving. I add b to both sides, okay? And one answer, x equals b. We know b is positive. So one of my x-intercepts is going to be on the positive side of the x's, right? This one's on the positive side. Positive side. Oh, this has positive side here. And this one's on. Okay, so that's good. But let's look at x plus a. Okay, if I have x plus a equals 0, now I subtract a from both sides. So now I've got an answer on the negative side. Okay, negative is over here. On the x-axis, these are negative values. These are negative values. These are negative values. The problem is, okay, and I want you to pay attention to this more specifically, this one is squared. So when I solve for a, anytime it is a multiplicity, which means technically I have two x plus a's, right? X plus a squared is this. So if I were to solve that, I really have two answers where x is negative a. Okay? Anytime I have more than one answer, okay, I have one b, but I have two negative a's. That's not a normal x-intercept, meaning when I graph something, it normally goes through there once, right? Like it does for my b value. But if I have two answers, it tends to go but not go all the way through. Right? So on my negative side, I should have something that looks like this. Okay, it touches the x-axis but does not go through it like it does when there's only one answer. So for my positive, okay, I'm going to erase all this. Okay, and I'm going to erase all of this. So if I were to sketch this function, and let's say here's where we have a positive b, and here's where we have my negative a. My graph is either going to come through here. Oh, there you go. It's either going to come through here and touch but not go through because there's a multiplicity of 2. Then come through like this. It's going to be like that in the red. Or it'll flip. It'll come touch and then go up and go through. It's either one, but my A on the negative side, it's going to touch and not go through, just like this right here. And then it'll go through on the positive side. So the answer is choice 1. I like problem 6. We're going to use a calculator for it, kids. The equations y equals 3t plus 6 and y equals 1.82 raised to the t approximately model the growth of two separate populations where t is greater than 0. What is the best approximation of time t at which the populations are the same? So just for reference, I'm going to graph these. The t is my x value. X has to be bigger than 0. And they want to know what x is. Well, I'm just going to graph this in y1. Okay, I'm going to graph this in y2, and I'm just going to see where they intersect. Okay, but keep in mind I want a positive value. All right, so let's go ahead and do just that. Bang. Here we go. Oh, I love my calculator. And I'm going to go to turn this on. I'm going to go to y equals, clear this out. And the first one is just 3x plus 6. And I move down here, and the next one is 1.82. I bet there were Blink 182 fans, whoever wrote this problem. 1.82 to the x. And you could put the 182 in parentheses, that's fine. And if you feel a little nervous, you're like, I'm going to write it exactly like they do on the test. There you go. Write it like that. Delete this out. Delete. Gone. That's fine. That would have given you the same thing. So I'm going to graph this. And I have a 10 by 10 window here. There's my first one, the line, 3t plus 6. And here comes my 1.82 raised to the t. All right, I see a point of intersection here. Okay? That. And it looks like that's around, if I do second trace intersect, and I move my little spider dude close to this point and hit enter 3 times. Look at the bottom left. Okay, negative 1.89. I look here, and if I round that, here's the answer, but it's not this. Remember, my t has to be bigger than 0, my x, so I can't have a negative answer. So as I look at my graph, you might be saying to yourself, well, Visca, I don't see where it intersects. Keep in mind, off to the top right, they're going to intersect again. So let me see higher up. I can just zoom out. I could have changed my window, but I'm just going to zoom out. And here comes 3t plus 6. And here comes 1.82 raised to the t, or the x, we should say. Bam, there's that second point of intersection right there. So now I'm going to go second calc, and pick intersection, which is 5. And I'm going to move my little spider dude closer to the other intersection point and hit enter 3 times. And if I look at the bottom, it's 5.11. So it's choice 3. So look at that first intersection point is it's an option, but the answer, it isn't even on the window if it's just 10 by 10. They try and get tricky there, but you're smarter than they are. And they continue to be a little tricky with number 7. If y equals negative 2x and x squared plus y squared equals 5, the point of intersection in quadrant 2, there's probably going to be more than one point of intersection. When I graph this, I hope you know quadrant 1 is here. Quadrant 2 is this upper left quadrant. I don't care about anything else. Okay, I just want the intersection in this quadrant. All right, so let's graph these. The problem is this is easy to graph. Okay, I'll put that in y1. I need to get this in y equals. So if I have x squared plus y squared equals 5, the first thing I'm going to do is subtract x squared from both sides. Now, if you have one of those fancy Inspires, you can graph this just like that. Okay, I'm using a TI-84 Plus, so I need to have it y equals. But the Inspire lets you put it in the graph just like this. You don't have to get it y equals. It's fantastic. All right, so now I have y squared equals 5 minus x squared. Well, I still don't have my y alone. I got to take the square root. Here's where the gotcha moment might happen. Y now equals the square root of 5 minus x squared. But anytime I undo a square, I need to have a plus and minus. Okay, so this is the first aha moment. Okay, the second being, I can't graph by putting a plus or minus. Okay, I need to have two graphs to represent this. I need to have one graph be a positive square root of 5 minus x squared, and I need to graph a second one where it's negative 5 minus x squared. Like this one, I'll put in y2, and this one, maybe I'll put in y3. Or there's another red, because I like to keep everything the same color. But these need to be two separate graphs. Okay, in case you didn't realize, this up here, that's a circle. So when I look down here, this is probably going to be the top half of the circle. This is probably going to be the bottom half. Okay. Again, we're only focusing on quadrant 2. So let's go ahead and do this right now. There's that. And there's that. The first one is negative 2x. Okay, so I'm going to turn this on, go back here, clear this out. And the first one's negative 2x. Now the next one was the square root of 5 minus x squared. Oops. Boop. There you go. But that's only I need the negative version. So if I scroll down here, okay, there's going to be another red colored graph. Where is that? There it is, a 9. So now I got to do the negative square root of 5 minus x squared. Okay, and when I graph this, let's make sure my window is my standard. I go zoom right to the standard one. That makes it 10 by 10 again. Here's my negative 2x. And here's my circle, the top half, and there's the bottom half. There you go. Now keep in mind, this doesn't look like a circle because this is kind of shaped like a television. It's wider than it is taller. But if I were to make this window into a square, now look at my circle right there. Now it looks like a real circle. And keep in mind, I only care about quadrant 2. I don't care about this quadrant. I only want this intersection in quadrant 2. So I'm looking for this point right here. So let's go back to our calculator and figure out what that point of intersection is. Second, trace, intersect. I gotta hit enter. And then keep in mind, I need to be on the top half of the circle. If your spider is in the bottom half of the circle, you want to make sure it's in the top half. And the answer is at negative 1, 2. That's the coordinate. Negative 1, 2 at the bottom. Negative 1, 2. Yep. Let's get rid of this poo-poo. Negative 1, 2 gives me the answer. It's choice 4. A lot of explanation, but if you know what you're doing, this wouldn't have taken a lot of time at all. One more problem and we're done. Oh, I love dividing. I love dividing two polynomials. It's like doing a Sudoku. Like I like solving puzzles and riddles. It's just cool to me. And this is cool to me. All right, there's really two ways we can do this. I could do the reverse tabular where I take the x minus 3 off to the side here, and then I find the things and the answer, I wrap around the numerator here and my answer is what's up here. But I'm not going to do that. How come? Because I notice at the bottom is a 1x plus or minus a number. That means I can use synthetic division. Okay? So what I'm going to do is I'm going to take my x minus 3 and solve that factor like I'm team voting it. X would equal 3. That goes in this little kind of box here. And then I've got to take a look at the numerator. Okay? Uh, I notice that I have a power to the 4, but I don't have a power to the 3. I just go power to the 2. This is a power to the 1. I'm talking the x exponent. And this technically has 0 x's. So if I start with my 4 and I count down, I'm missing a 3. That's considered a missing term. So when I rewrite the top half of this, I'm going to say I have 2x to the 4th, but I have 0x cubes. You need to write every term. Minus 5x squared minus 3x minus 2. This is the numerator. And all of those coefficients, the 2, the 0, the negative 5, the negative 3, and the negative 2, I'm bringing down without the x's. So I've got my 2, my 0, my negative 5, my negative 3, and my negative 2. And I draw a line with some space below, okay? I always just drop the first term. Whatever's down here gets multiplied by this. And that product, 2 times 3 is 6, that product will always get added to the next term. And I just repeat this until I'm done. Okay, 0 and 6 is 6. Now I multiply 6 times 3 and get 18. That will get added here. All right. 18 minus 5 is 13. This will get multiplied times my 3. That's 39. You can use a calculator if you want. I add these. 39 minus 3 is 36. 36 times 3 is 108. Okay, I lied. Ooh, I just caught something. See how I wrote negative 3 here? Maybe you caught it. That should be a positive 3. Ooh, good catch, Visca. So 39 plus 3 is 42. 3 times 42 is 126. And I subtract 2. That gives me, I know I say add, but a positive 126 and a negative 2, it's like I'm subtracting 2, is 124. Now, here's how you read your answer. Man, I'm glad I caught that. This last number is the remainder. When I write my answer, this has 0 x's, this has an x to the 1, this has x squared, and this is x cubed. So I have 2x cubes. That's a positive 6x squareds. It's a positive 13x, and plus a 42. And my remainder is a positive 124. The remainder always go over what we're dividing in, the denominator. X minus 3. That's your answer there. Man, I'm glad. There it is, 124. 124 over x minus 3. Everything else matches. I am glad I caught that mistake because when you go fast, it is real easy to make mistakes. 23 minutes. We did 8 problems. I mean, what's that? 3 minutes a problem? We're good. We're good, kids. I'll see you for the next set of questions, which will be 9 through 16. Peace.
Don't forget to subscribe and ring that bell.